These are your notes for section 6-2, and today we're going to talk about absolute values, square roots, and some quadratic equations. This is a journal choice for you. Design a pie shirt. The winning design will be awarded a free shirt, and you will have the chosen one. So if you want to participate in that, please do. Objective and what's the point? We're going to review some relationship between absolute value and square roots, and I won't be surprised if a few of you are a little confused about some of the things we do with absolute value today, because it is a little bit confusing. But hopefully it all comes together at the end. Okay, and we're going to solve some quadratic equations, some absolute value equations, and do some graphing. Okay, absolute value is useful when examining distance because by definition, absolute value and distance are the same thing. So what is absolute value? Okay, absolute value, these are the symbols. They look larger than ones. Absolute value of n has a little bit longer bars. Geometrically, and this is the thing that makes sense to kids, it's the distance of n from 0 on a number line. Some kids always say, it's positive or it's the opposite. No, it's not the opposite. It's the distance. It is always positive because distance is always positive because there's no such thing as negative distance. If you've seen the movie Ferris Bueller, he tries to take miles off a car by throwing it into reverse, and you can't do that. No matter what, if I'm coming from here to Grafton, let's say it's 15 miles. If I go from Grafton back to Jerseyville, that does not make it negative 15 miles. There's no such thing as negative distance. Distance is always positive. As a result, absolute value is always positive. This is what I think you will think is a little confusing. The absolute value of n, it's going to be x if x is greater than or equal to 0, and it's going to be the opposite of x if x is less than 0. Basically what they're doing here is they're describing the graph to you. The absolute value of n has a vertex right here at 0, 0. It's going to split it into two pieces. Okay, the right hand side is going to be the absolute value of x with a rise of 1 and a run of 1, which my graph is a little bad. Rise of 2, run of 2. Okay, in quadrant 1. On the left side of the vertex, it's going to have negative slope, and it's going to make a V-shaped graph. You do need to know absolute value has a V-shaped graph. This is the part that will cause you some problems. This is determined by where your vertex is. It is not always 0. It's going to be where the vertex is. That's going to be the break in the graph. Okay, and we'll talk about that in a second. Is this a function? It is a function, yes, because it passes the vertical line test. But it is a V-shaped graph, and that's something you're going to need to know. Okay, suppose we have this graph. I actually have the answer here. Pretend that's not there. Write a piecewise definition for f. Okay, well, it's going to be f of x equals x minus 1 for x greater than or equal to 1, and negative x plus 1 for x is less than 1. This part of the graph came from negative what was in parentheses. We distributed it, and you get negative x plus 1. The first part of the piecewise is exactly what is written inside the absolute value sign. So that's where those two things came. This part, again, is where that vertex occurs. The easiest way for me to graph absolute values is with a t-table. Okay, if I plug in 0, 0 minus 1 is negative 1. The absolute value of negative 1 is 1. So over 0, up 1 is on my graph. Plug in 1. 1 minus 1 is 0. The absolute value for 0 is 0. Plug in 2. 2 minus 1 is 1. Absolute value of 1 is 1. And then I can see where the vertex was. Once you have that change in motion, that's where the vertex was. The other way you can tell is where will this inside equal 0? Because when it equals 0, that's where that breaking point is from getting the positive values to the negative values when you take the absolute value. So if you're looking for where this switch for your piecewise is going to occur, it's going to happen when this absolute value quantity is equal to 0. But if you want to avoid this altogether, you could just do a t-table and then come up with the equations afterwards. By knowing it's two lines, this is my break, you can do point slope formula from each side if you want. Something to think about. You won't have to write many piecewise functions of this, but it is definitely something I wanted to address with you. Okay, how do you solve absolute value equations? Because this is an absolute value equation because there's an absolute value sign and then there's equal signs making it an equation. Here are the steps. Step 1 is going to be to isolate the absolute value. And step 2 is going to make 2 problems. And you can remember this because I will always say it. 2 bars means there's 2 problems and you will solve each. So let's look at this first one. The absolute value of t equals 5. Step 1 is to isolate the value, absolute value, and it's already isolated. The absolute value is all by itself. Step 2 is to make the 2 problems. Okay, here's the deal, and I'm not going to necessarily make the 2 problems here. I'm just going to talk this out with you. This is saying the absolute value of some number, we're trying to figure out what that number is, equals 5. Some numbers, distance from 0 is 5. Well, we know there are 2 numbers whose distance from 0 is 5. What are those 2 numbers? 5 and negative 5. And those are the 2 answers, t equals 5 or negative 5. Okay, this next one is a little more confusing, but it will make sense once we get going here. Let me erase some of that. Okay, step 1 is to isolate the absolute value. In this case, I do have to do something there because there is a plus 7 on the same side, so I'm going to subtract 7. The absolute value of 2b minus 3 equals 12. Now, 2b minus 3, once I figure out what b actually is, this is just some number in here. So once again, the absolute value of some number is 12. There is some number whose distance from 0 on a number line is 12. Well, we know there are 2 numbers that could be. It could be 12 or it could be negative 12. Here's where the 2 problems come in. I now have 2b minus 3. That could equal 12, and that would have an absolute value of 12. Or 2b minus 3 could equal negative 12. Those are the 2 problems. We can solve them. 2b equals 15. b equals 15 over 2, or 7.5. I like 15 over 2 better. Okay, second problem, plus 3 plus 3. 2b equals negative 9. b equals negative 9 over 2. When I plug in negative 9 over 2 and 15 over 2 into this equation, I will get 12 and I will get negative 12. But the absolute value of both of those equals 12, so that's why there are 2 answers. I'm going to tell you right now, you are going to forget the 2 answers. There will be kids in here who will miss that question on the test, and it's not that hard. You'll even say, oh, 2 bars, 2 answers, and you won't write the 2 problems down. Okay? And they're not always opposite. Some kids always want to say, oh, it's 5 and negative 5, because up here it was 5 and negative 5. That's not what it would be when you plug it in. They will not always be opposites. They barely ever will be, actually. Okay? Let's look at the last one here. This is already isolated, so we're good to go. This is saying the absolute value of some number is negative 3. The distance from 0 of some number is negative 3. This should not make sense to you. Distance from 0, negative 3, there's no such thing. So there is no solution. There is no number that could have a distance of negative 3 because negative distance does not exist. So if you have isolated your absolute value like this one and you have a negative number here, there will be no solution. Make sure you jot that down in your notes somewhere so you don't mess that up later. Okay, square roots are related to absolute value. And this is a graphing calculator activity that I'd like you to go through, and it is in your book, and it's on page, I think, like 381 it looks like. Okay, oh, it's kind of hard to see. That's unfortunate. In each row of the table, choose the value of x satisfying the constraint, then evaluate f of x and g of x. Okay, f of x is going to be the square root of x squared, and that's underneath the square root. And this is going to be absolute value of x. Okay, we'll just do this by hand. They do want you to graph them both on the same axis with the graphing calculator, and we can do that in class tomorrow if somebody will remind me, please. And you're going to see this relationship. Okay, let's pick a number less than negative 10. Okay, how about negative 20? So that's what we're going to plug in for x. F of x, negative 20 squared, that's 400. Positive square root of 400 is 20. So f of x is 20. Absolute value of negative 20, 20. Okay, that's the first one. Let's look at the next one. A number between negative 10 and negative 1. How about negative 5? Square root of negative 5 squared, that's the square root of 25, that is 5. Absolute value of negative 5 is also 5. Okay? How about a number between 0 and negative 1? I like negative 0.5 or negative 1/2. Square root of negative 0.5 squared. So square root of 0.25, which is positive 0.5 or positive 1/2. Absolute value negative 0.5 is, oops, why am I writing that down? 0.5. 0 is already done for us. If I go back through here, I think you will see, if I pick the same types of numbers, the same thing is going to happen. Except there won't be sign changes from x to f of x. I'm going to pick here 20. Okay, why is this? When you take a negative number and you square it, what happens? It becomes positive. When you take the square root of something that has been squared, you undo that. So you are, in essence, making it positive. Because of that, the square root of x squared will always equal the absolute value of x. This is going to make it positive. This is going to undo the squaring. This always makes things positive. So in essence, this is always making things positive. Now we know that absolute values have two solutions many times when dealing with equations. And as a result, when you take a square root of something that's squared, you are also going to get two solutions. And it is also something kids forget a lot. So we are going to look that over right now. You're going to write this theorem down in your notes. The square root of x squared equals x. And this is how we're going to solve quadratic equations. You're going to isolate the exponent or the squared term. We're going to take the square root of each side. And then we're going to use the theorem to make two problems. And step double 2, I don't know why I can't make my steps right. This should be 3. And this is 4. Step 3 is what kids are going to forget. You're not going to make two problems and you're going to miss one of your answers. Square root's going to have two answers also when we're solving them, just like absolute value. Okay, so let's look at an example here. What number squared is 25? This is what kids do all the time. Square root, t equals 5. Oh, how great. Not. Because what number squared is 25? 5 or negative 5. There are two numbers that when you square them equal 25. So hopefully what I'm hoping you will do is when you take the square root of t squared, you're like, oh, square root squared. That's the same thing as absolute value of t equals square root of 25. Then you'll remember two bars, two problems, square root of t equals 5 or negative 5. Okay, this second problem, I got to get x squared by itself. Subtract 81, subtract 81. 3x squared equals 9. Still isolating the squared term, divide by 3, x squared equals 3. Square root both sides. Oh, that's the same thing as absolute value of x equals the square root of 3. What numbers distance from 0 on a number line is the square root of 3? There are two. X could equal square root of 3 or negative square root of 3. There are two things I could plug in there to get that distance from 0. Okay, a couple more words you need to know. A rational number is a number that can be written as a simple fraction, 1/2, 1/3, 3/4, -2, because I can write that as -2/1. Okay, an irrational is a number that cannot be written as a simple fraction. Infinite, non-repeating decimals, so like 0.101, 001, 00001, 00001. That would work. How about pi? And these are the biggies. Square root of 2, square root of 3. These square root numbers are always going to be irrational. Except square root of 4. Square root of 4 can be written as a fraction because that's 2/1. Okay. So last thing, we are going to graph these two graphs. I'm going to tell you, go with the t-table. Your graphing calculators can graph these, and I can explain that to you in class, but I do want you to do these by t-table here. X, Y, we got to find that vertex, that breaking point. Let's plug in 0 first. 2 times 0 is 0, absolute value is 0, 0. Plug in 1, 2 times 1, absolute value of 2 times 1 is just 2. Plug in negative 1, absolute value of 2 times negative 1, that's negative 2, which is 2 again. That should be enough. Once you have this going here, you will see that this oftentimes is the slope or a key indicator of what it will be. Okay, how about this one? Do an XY table. Plug in 0. Absolute value of 2 times 0 plus 6. 6, absolute value of 2 times 0, 0, 0 plus 6. So 6, 6. So over 0, up 6. Barely make it here. Let's plug in 1. 2 times 1 is 2 plus 6. That's 8. That's too big, so I'm not going to go that direction. Let's go the negative direction. Negative 1. 2 times negative 1 plus 6. Negative 2 plus 6 is 4. Absolute value of 4 is 4. So negative 1, 4. Looks like I can see what the slope is going to be here. Give myself some space. Let's jump down and plug in negative 3. 2 times negative 3 plus 6, absolute value. Negative 6 plus 6 is 0, and that's the one I was waiting for. You can tell what's going on here. I'm going to plug in negative 4. 2 times negative 4 is negative 8 plus 6. There's that rebound effect. Negative 8 plus 6 is negative 2. Absolute value of negative 2 is positive 2. There's where the V is. So you're going to keep going until you can find that vertex. Again, oh, that's horrible. You can tell where that vertex is going to be. If I set 2x plus 6 equal to 0, it will tell you 2x is negative 6. Negative 3 might be a good spot to start your ordered pairs, and that's exactly where that vertex was. All right, so you're going to do some graphing too. All right, I think that's all I have for you. Those are the book problems we'll be doing tomorrow. If someone wants to jot those down, that'd be great.